Assalamu alaikum students. Today we start exercise 1.3. And first question, we draw a graph of different complex numbers. It is also we done in last examples. I think easy for you. If you have a single point, then if you have a real point, then imaginary is 0, and if you have a imaginary point, then real is 0. Same question as exercise 1.2, multiplicative inverse. Every number has its multiplicative inverse except 0. Multiplicative inverse of z is 1 over z, and then we rationalize it. We rationalize with the conjugate, change the sign of imaginary number, and then simplify it. Same multiplicative inverse, these questions. Simple way is to make it inverse and then rationalize it, and the other method, we develop a formula for this. Z is equal to a plus b iota, then 1 over z at the end is equal to, we solve it and get a answer a over a square plus b square minus b over a square plus b square. General formula for the multiplicative inverse. We can use this formula if you learn it, and then use like here. In this question, a is minus 3, b is minus 5, and put in the formula and we get the result. Otherwise you can directly rationalize it and get the same answer. In next question, simplification. Same like exercise 1.2. If you have an odd number, then reduce its power by taking 1 iota and it becomes even, and then simplify it. Even power of a negative number is become it positive. If power is a negative number, then reciprocal make it positive, and then simplify. If you have iota in denominator, then rationalize it. Simple questions. Next, short proof. Prove that z bar is equal to z if z is real. IFF means if and only if both conditions are true. Let z is equal to a plus b iota, z bar a minus b iota. If they are both these conditions are equal, then the result is b is equal to 0. We put in the z, it becomes a plus 0 iota, which is real. Then we taking its bar, it also become is equal to a, therefore z is equal to z bar. We start from the first condition and produce a result z is real, and then show that they both z and z bar are equal. Then is simplification. Minus 4 square root is equal to minus square root is iota, and 4 square root is equal to 2. Then multiply these two brackets. If you have iota square is equal to minus 1, and then simplify them. In second part, minus 3 square root. Square root of minus is iota, and 3 remain in the square root, and then multiply these equations, these brackets. In third part, we have a fraction minus 8 square root. Minus is equal to iota, and then rationalize these and simplify like multiplicative inverse. In this part, minus 12 square root, minus square root is equal to iota, then rationalize these fraction. Always in the denominator we use the formula, difference formula, a minus b multiplied by a plus b becomes a square minus b square. Simplify and we get the answer. Next condition to prove z square plus z bar square is a real number. Let z is equal to a plus b iota and z bar a minus b iota. Then put these values taking square and sum, and we get a result without iota, a number which has no iota. It is called real number. In this bracket whole square, we first simplify the inner values and then taking square, and this is also become a real number. Last question, simplify taking cube. As we know the formula of cube, a cube plus b cube plus 3ab in bracket a plus b. A is equal to minus 1 over 2 and b is equal to square root 3 iota over 2, and put these values and then simplify. Cube of a negative number is negative. Cube of square root 3, we can write it as square root 3 and square root 3 whole square, and iota cube, iota and iota square. Then further simplify, replace iota square by minus 1, and we multiply the value in bracket distributive property, multiply by both numbers, and we get the same values with different signs and cut each other, and then further simplify and we get a good answer 1. It is very important question. Do it twice. And then same question with both negative values. If both negative values in a bracket, we should common a -1, and the same power on the -1 is cube. Cube of -1 is minus, and in the bracket is the same value as the we solve in first part. Solve it and get the same answer as we get in 1. Next, we have same values in bracket, but one bracket contain a power -2 and one without power means its power is 1. If two values multiply, then their power add. -2 plus 1 means -1, and -1 means taking inverse of this fraction and then rationalize. We get the same answer. In this question, whole square, a square plus b square plus 2ab. I think simple question. Fifth part, we have a negative -2. Make it positive. We inverse the value 1 over a plus b iota, it becomes positive. Then taking square, and then we rationalize. And when we rationalize, we change the sign only with the value of iota. Plus 2ab iota, and we multiply by we rationalize with the value -2ab iota. Real part is same, a square minus b square. Denominator will remain same, and in numerator will same, and denominator apply the same formula, a square minus b square, and then simplify. Iota square is -1 and plus minus these values, and we get in the denominator a plus b whole square. Important question. In next part, 3 minus 4 square root whole power -3. -4 means 2 iota. Square root of 4 is 2. Square root of -1 is iota, and power is -3, so it's become 1 over 3 minus 2 iota, and then rationalize these values. Three plus 2 iota whole cube in numerator, and in denominator we apply a square minus b square and its cube. We apply the same formula of cube, a cube plus b cube plus 3ab, and in bracket a plus b, and then simplify. Cube of 2 is 8, cube of 3 is 27, cube of iota is iota square and iota, and at the last term we apply distributive property, multiply these values in bracket, and in the denominator we get 13 whole cube is 2197, and then simplify it. I think this is the last question. Do these questions at least one time, and also an example of polar form. It is very important for the both point of view. Good luck, and if you have any problem, contact me with me. Allah Hafiz.